Okay, let's go ahead and read through this problem. Teresa and Jordan meet up at the campus coffee shop for a quick chat. But after checking the time, they realize they're both running late for class. Teresa hops on her skateboard and heads east toward her engineering lecture at a steady speed of 6 miles per hour, while Jordan power walks north toward the humanities building at 4 miles per hour. After 10 minutes, how fast is the distance between them increasing? Okay, so we already have a little bit of a diagram started for us here, but we've read through the problem. And what we want to understand is how fast is the distance between them increasing? And so we have one person walking north and one person walking east. And so as they're getting further and further apart, the distance between them is increasing. What we want to also figure out is that if this were just a problem where I was asking you, how far apart are they? This could be a Pythagorean theorem problem. And so that's actually going to be part of what we're going to do here. What do we actually want in this problem where it says how fast is the distance between them increasing? We're going to have a rate as our answer. And so 4 miles per hour, that's a rate. 6 miles per hour is a rate. And so our distance that they're increasing, that's going to be in terms of that hypotenuse on here. We're going to have, if I decided to call this side A and this side B, then the hypotenuse between them would be our C value. And the rate we would be looking for then is the dc dt. Okay. So that's kind of our setup to the problem. What I'm going to do is write out my Pythagorean theorem. A squared plus b squared is equal to c squared. And then implicitly, this is going to be a function in terms of time. If I differentiate this with respect to time, what I'm going to need to use is the chain rule, but I'm going to go ahead and say derivative of a squared is 2a, but then with respect to time, I need to write dA dt. And then plus, when I differentiate the b squared, I'm going to have 2b. And then when I differentiate with respect to time, I've got dB dt. And finally, same thing for my c. I'm going to have 2c. And then differentiating with respect to time, dc dt. In this form, we can actually see the quantity that we're hoping to solve for here. I'm going to go ahead and rearrange this equation by dividing both sides by 2c. Okay, and so if I do that, then these will cancel out and I'm going to have the dc dt by itself. This 2, I can factor a 2 out of both of those pieces here. So if you forgive me, I'm going to kind of skip a step here and go ahead and just cancel that 2 out of all 3 pieces. And what we're going to get left with is a times dA dt plus b times dB dt, all divided by our hypotenuse c, will give us the value dc dt, the rate that we are looking for. Okay. Well, we can tell that in order to find this dc dt, we're going to need the side length A, we're going to need the side length B, we're going to need the side length C, and then we're also going to need 2 rates. Now, we actually have the 2 rates that we're looking for here. This 4 miles per hour, that's alongside A the way I've labeled this. So this is my dA dt. Okay, and then I also already have my dB dt. That's my 6 miles per hour here. So this is my dB dt. What I don't actually have are the side lengths, though. So we're going to have to use the Pythagorean theorem, but I actually am going to need side lengths to plug in order to make that work. And that's where we're going to use this 10 minutes part. 10 minutes, and our rates are in miles per hour. I need to turn that minutes into a fraction of an hour. So 10 minutes is actually 1/6 of an hour. And we're going to use that in order to find some side lengths here. So if I take that 4 miles per hour for side A, so I'm going to write 4 miles over hours. Okay, so 4 miles per hour, and I'm going to multiply by 1/6 of an hour. This grid thing that I'm doing is called dimensional analysis. You don't have to set it up this way, but it helps me see that what I can do is go ahead and cancel out the hours here. I'm going to go ahead and multiply the 4 times 1/6. That's 4/6. And then the only unit that didn't get canceled was miles. So 4 miles per hour times 1/6 of an hour is going to give us 4/6 of a mile, or 2/3 if I want to simplify it. 2/3 of a mile. That's our side length A. So up here, the A is equal to 2/3 of a mile. Okay. Side length B, I can do the same thing. I'm going to use that 6 miles per hour. And we're going to multiply that by 1/6 of an hour. Which again, I can see my hours are going to cancel out. So I'm multiplying the 6 times 1/6. That's just 1. And then the only units that didn't cancel out are miles. So I have 1 mile there. So my B side length is 1 mile. So with the Pythagorean theorem, I need 2 of the side lengths. I've got my A and I've got my B, so I can go find that C. So I'm going to go ahead and do that over here. So in my A squared plus B squared is equal to C squared, I'm going to go ahead and plug in my 2/3 for the A. So 2/3 squared plus, and I'm going to go ahead and plug in the 1 mile for the B. 1 squared is equal to C squared. 2/3 squared, that's going to be 2/3 times 2/3. That's going to be 4/9 plus 1 squared is just 1. In order for me to combine them together, I'm going to write that 1 as 9/9. We agree that's still 1. So that will allow me to have like terms for those fractions. So I'm going to have 13/9 is equal to C squared. I don't want C squared though, I want C, so I need to take the square root of both sides. And so I'm going to get the square root of 13 in the top. Square root of 9 is just 3. And that's going to be my missing side length C. Okay. So I now have my A value. That was the 2/3. I now have my B value. That was the 1 mile. I now have my C value. That's the square root of 13 over 3 miles. And then the 2 rates, the dA dt, that's the 4 miles per hour, and the dB dt is the 6 miles per hour. So I have everything I need. I just need to go ahead and plug it into this formula. So my A value, 2/3 times dA dt is 4 miles per hour. So I'm just going to put 4 over 1 plus my B, we said, is just 1. I'm going to go ahead and write that as, I'm just going to keep that as a 1, and then times the 6 miles per hour. 1 times 6. In the bottom, we're going to write square root of 13 over 3. Got a little bit of simplifying to do here. In the top, I've got 8/3 plus 6. And if I want 6 to be over 3, what I can do is multiply by 3/3 so I can combine those together. Nothing happened to my denominator here. So I now have 8/3 plus 18/3 divided by square root of 13 over 3. Go ahead and move this down a little so you can see where I am. We're going to put these together. 8 plus 18. So my 8 and 8 is 16, and we'll carry the 1. So I'm going to have 26 here over 3. And we're going to divide by the square root of 13 over 3. If we divide a fraction by a fraction, we're going to keep that top fraction. We're going to change this division bar into a multiplication dot, and then I'm going to flip over that bottom fraction. So we're going to put 3 over the square root of 13 now. And we can see that these 3's are going to cancel here on the diagonal. So I have 26 over the square root of 13. Mathematically, there's nothing wrong with that, but usually we don't leave a square root in the bottom. So the way we fix that is we multiply top and bottom by the square root of 13. This is called rationalizing the denominator. And so we have 26 times the square root of 13 in the top. The square root of 13 times the square root of 13 is just 13 down here. Oops, sorry, I didn't write my 6 here. 26 times the square root of 13. So 26 divided by 13 is just 2. and then square root of 13 is here. What would our units be? Because we are finding a rate, so we were hunting for our dc dt, that's in miles per hour. So we have 2 times the square root of 13 miles per hour.